Hey, this is Math 7, Unit 6, Lesson 15, Efficiently Solving Inequalities. And so, as we start today's lesson's a little bit longer than normal, and so sorry about that, but it's just a little more complicated in what we're doing today to help you understand the reasons why it works the way it does when we start talking about inequalities and what happens with the direction of this inequality symbol there. And so one of the things we've been talking about a little bit are kind of what we would refer to as our boundary points. Okay, those would be kind of the upper or the lower limits of what a variable could be, an x could be, whether it's going to be greater than 2, less than 2, what those boundary points are going to be. We have to figure out what those are going to be in order to then determine the direction of the inequality. And so we're going to solve some problems today to talk about, we're going to solve some problems to determine the direction of inequality by first defining the boundary points and then using some reasoning skills to determine which direction the inequality should be going in. So let's take a look at the first one here as an example. It says here's an equality, negative x is greater than or equal to negative 4. And so one of the first things you notice is that we have a negative coefficient, right? A negative is in front of that variable. You could rewrite that if you wanted to as negative 1x greater than less than negative 4. It doesn't change anything, but it just tells you that there's a negative coefficient in front of the variable x there that is causing this to be a little different. So when we have to predict what this would look like, one way we could go about doing this would be, first of all, to pretend this was going to be an equal sign. So instead of an inequality, set it up as an equation, right? So if we did a negative, we could do negative 1. Sure, let's do negative 1 times x is greater than equal to making it an equation, is equal to a negative 4. If I saw this, I would divide both sides by negative 1 by negative 1, and x is equal to 4. All right, that becomes my boundary point for what we're going to talk about next, my boundary point. So now in terms of knowing my boundaries of 4, that means if I have a number line, and here's 4, I'm either going to go this side of the 4 or that side of the 4 for values that are going to work for this inequality. So if I did a value of x being less than 4, that's one option, or I could have values of x greater than 4. At this point, I can go back to my original equation, which is negative x is greater than or less than 4, and I can select a point. For a value less than 4, pick a number you're comfortable using. I can go right to the left of it. For this one, I could do a 3, right? 3 is less than 4. And a number greater than 4, I could use 5. Now I can take that number that I'm just testing out and using some reasoning skills to see what happens. If I was to put a negative, and then this is where the x is, 3, is that greater than or equal to negative 4? Is negative 3 greater than or equal to negative 4? Yes, it is. So this is a true statement. Over here, if I use the 5, if I had negative 5, is that greater than or equal to negative 4? In that case there, that would be false. It's a false statement. So when I take a look at the true statement will tell me what direction my inequality needs to go. So my solution for this would actually be then x is less than or equal to, because still less than or equal to 4. That's going to be my solution for this inequality. All right, so if I work that out, I end up with x is less than or equal to 4. Now, when I look at my terms over here, I can figure out which one of those options is less than or equal to 4. 3 is less than or equal to 4. Negative 3 is less than or equal to 4. 4 is equal to 4, so it counts. Negative 4 is less than or equal to 4. 4.001 is greater than, so that will not work. And negative 4 is less than or equal to 4. All right, so now when I graph this out, if I was to graph out the points, I can start here at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, right? And so my values that are working here, I have 3, that works, no problem. Negative 3 works, no problem. 4 is working, no problem. Negative 4 works, that one does not work. And then negative 4.01, so maybe someplace like here. All these values from 4 on down are all solutions to the inequality. Those all are all numbers that would work. So what do we do here? We found our boundary limits by making the inequality into an equation to figure out what our boundary point was going to be, the 4. And then we had to make a determination on the direction of the inequality, whether it was going to be less than or greater than. We picked a point to kind of to reason with, and plugged it back into our original inequality, and then saw what would happen and decided if it was true or false. If it's true, that determines the direction of the inequality. All right, let's look at section number 2, inequalities with tables. So we're going to investigate the inequality x minus 3 is greater than negative 2. First it says complete the table. So to do this here, we're going to go ahead and we're going to take the value that's given on this part of the table and plug that into this part of the equation here. Right? So negative 3 minus 3 is negative 6. Negative 1 minus 3 is going to be a negative 4. 0 minus 3 is negative 3. And you can see the pattern here, negative 2, negative 1, 0, and 1. So for those values, that's what I end up with is that table right there. So table complete. So for which values of x is it true that x minus 3 equals negative 2? So what value of x can I put in there where it's going to equal negative 2? And when I look for my table, I can see that happens right here when x equals 1. So when x equals 1, the solution works out to be negative 2. Now, for which values of x is it true that x minus 3 is greater than negative 2? So where, in terms of these numbers here, when I look at all these numbers, when I plug these numbers in, when are they greater than negative 2? Notice it's not equal to negative 2, it's greater than number 2. So in this case here, these values all in this range are all going to be greater than negative 2. When I plug 2 into it, it's greater than negative 2. When I plug 3 in, it's greater. When I plug 4 in, it's greater. So what we could say then is that it's all values where x is greater than, in this case here, here's our 1, greater than 1. And I say greater than 1 because we know that 2 works, 3 works, so it's not just greater than 2 because 2 itself works, but 1.0001 works as well. So as long as it's greater than 1, it's going to be a solution there. So when I graph this solution, I put a 0, 1, 2, 3, negative 1, negative 2, negative 3. And so a solution for this equation is going to be an open circle at 1, because it doesn't include 1, and an arrow pointing to the right, which will include all values greater than 1. And that's the idea there for that one right there. Okay? Now, here's an inequality, 2x is less than 6. And again, we need to predict which values will make the inequality true. We want to have a value where this is going to be a true thing. So if I set this as an equation and did 2x equals 6, I would divide both sides by 2 and x is equal to 3. That becomes our boundary, right? That becomes our point where there's going to be a mark where x equals 3. So here's our 3 right there. That's our boundary. So now, if we want to see what's going to work, is it going to be greater than 3 or less than 3? That's what we have to decide. So is x going to be greater than 3 or is x going to be less than 3? We're talking now about the direction of that inequality based upon the boundary. So let's plug something greater than 3 in and less than 3 in. I could go with the 4 because here's the 4 right here. I have to solve it anyways, right? So if I did 2 times, we're going to do 4, 2 times 4, is that less than 6? Is 8 less than 6? We would say, no, it's not. That's a false statement. So it's not going to work there. If I did a number less than 3, like 2, is 2 times 2 less than 6? That gives me 4 is less than 6. That is a true statement. So that's going to work there. Now the 3 one we already know was equal to 6, so that's not going to quite work out. So this is our boundary point. We checked a point below it, a point above it. We found the one that was true was the x is less than 6. And so in terms of our solution, we know that x is less than, sorry, I said 6, x is less than 3. Ooh, that's a crazy 3. X is less than 3. And so any number from here down here is going to be a solution to that equation. Now what it wants you to do is to complete the table to plug things in. So let's do it. Negative 4 times 2 is negative 8. That is less than 6. Again, my goal is less than 6. That's my goal. Negative 3 is negative 6, negative 4, negative 2, 0, and 2. Are all of these values less than 6? We would say yes, they are. And so in terms of a graph, if I have 0 here, 1, 2, 3, 4, I know that 3 itself doesn't work, but anything less than 3 is going to be a solution to that inequality. Okay? And so that's the idea of what we're doing. Making a solution, an equation, finding a boundary, and then writing and deciding, okay, is it greater than your boundary or less than your boundary? Picking a point, plug that point back into your inequality, determining if it's true or false. Whichever one is true, that becomes your solution to the inequality. And then we're plotting out by verifying with a table and then making the graph. Okay, now this becomes important when you get to ones like number 3 and we start again dealing with a negative coefficient in front of that variable there. So let's take a look here. Here we have negative 2x, and we're going to make it an equation, equals 6. Let's divide both sides by negative 2, so x has to equal negative 3. What do we call this point? We call this our boundary. Okay, and so now what we have to decide is which direction will it go? Is x going to be greater than negative 3, or will x be less than negative 3? That's what we have to decide by saying which one's going to be a true or false statement. So in terms of a number being greater than negative 3, I could use something, because here's negative 3, that's my boundary. I could pick a number like 0, right? I could use 0 and put it back into my initial equation. So we'll do negative 2 times 0 is less than 6, and let's see if that's true. Is 2 times 0 is 0? Is that still less than 6? Yes, so that is going to be true. Now because this is true, when I put that in there, 0 in there is 0, and this is a true statement right there, I really don't need to do this side over here. I can't get a true statement both ways. I really can't. But for the sake of just the problem here, let's go ahead and do it. Let's pick the number next to it. We'll do negative 4. So negative 2 times negative 4, is that less than 6? Negative 2 times negative 4 is a positive 8. 8 less than 6, that is a false statement. So the one that is true is x is going to be greater than negative 3. X is greater than negative 3 is a solution to this inequality. So that's what we would say. So if I had to predict a value for a, I would pick any number greater than negative 3, which means I could pick any one of these numbers here and it would be a solution. Let's verify that by plugging numbers in. Negative 3 times negative 2 is going to be a positive 6. Again, we're looking for things less than, a number less than 6, so it doesn't work. Negative 2 times negative 2 is a positive 4. All right, and so that is less than 6. Negative 1 times negative 2 is positive 2. That works. Then I get a negative 2, I get a negative 4, negative 6, and negative 8. All of these values are less than 6. So those all are true statements. They would all work there. So when I graph this then, what I can do is I can graph knowing I have these numbers here. Here's negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. I know that I'm going to have any number greater than, not equal to, greater than negative 3 is going to be a solution for that inequality. How are these two solutions, 2x less than 6 and negative 2x less than 6, different? How are they different? Okay, on the 2x is less than 6, we said that 3 was our boundary, right? That was our boundary point there. But over here, negative 3 was our boundary. Now in terms of being a boundary, when we look back at our charts, let's see if I can get this all on here. 3 was the boundary, and that was what we kind of called our upper limit. It was the highest it could be. Over here, this was actually a lower limit. And it's not because it's positive or negative, it just happened to be which way it is. And in this case here, our solution was any number less than 3, and here it was any number greater than negative 3 became our solutions there. And those are the differences between those two equations. So that negative coefficient does change things quite a bit. So we have to be very careful about that. Okay, now we're going to go to activity number 3, which is called which sides are the solutions. And we're going to have several different equations or inequalities here that we have to work at solving and graphing, and kind of going through the process of finding what's the boundary and then testing some things out to find out the direction of the inequality. All right, so they begin by doing what we've been doing, setting it up as an equation and first solving. So if I solve this one, let's rewrite it up here so I have some space. I have negative 4x plus 5 equals 25. I would subtract 5 from both sides, so negative 4x equals 20. Divide both sides by negative 4, so that x equals negative 5. That becomes my boundary, x equals negative 5. So now I need to decide the direction. Is x going to be greater than negative 5, or is x going to be less than negative 5? And so I'll use my initial equation here. Negative 4 times some number plus 5 is going to be greater than or equal to 25, or some number times negative 4 plus 5 is greater than or equal to 25. Now, for what I want to plug into those spaces there, I want to pick a number greater than negative 5. I'm going to go ahead and pick 0 because it is simple to work with, easy to do, it's bigger than negative 5. So I put a 0 there. So negative 4 times 0 is 0. So I have 5 is 5 greater than or equal to 25. This is a false statement. So that's not going to work for us, is it? Which means automatically this one will, because I'm going to have one false and one true. But let's just verify. Let's pick a number that is less than negative 5. Let's go with a negative 10. Okay, just nice. I like working with zeros and tens. It's handy, right? So negative 4 times negative 10 is going to be a positive 40. 40 plus 5 is 45. Is that greater than or equal to 25? It is. This is a true statement. So in terms of our direction, we're going to say that x is going to be, and I should put equals here for you, x is going to be less than or equal to negative 5. So let's look at, I did kind of a lot of work here. That's just the pattern I'm going to use for the rest of the problems here. So we solved it first of all and said that x equals negative 5. Is this true when x equals 0? Well, we tried 0 and we said no, it's not true when x is 0. What about when x is equal to 7? If I plug 7 in there, you have negative 4 times 7 plus 5. Is that greater than or equal to 25? This becomes negative 28 plus 5, which is negative 23, greater than or equal to 25. That is also going to be a no, not true. And how about negative 7? Negative 7 is going to be negative 4 times negative 7 plus 5. That's going to be a positive 28 plus 5, which is going to be a 33 is greater than or equal to 25. That's going to be a true statement there. So negative 7 is going to be true. Does that correspond to what we said before, that x has to be less than or equal to negative 5? Well, that would be true. Negative 7 is less than negative 5, so it works. 7 is not. 0 is not. So in terms of graphing our solution here, we're going to graph this solution. We're going to write here negative 5. We can write a negative 4. We can write a negative 6. I can fill in the other numbers too, but I'm going to draw a circle. I'm going to close it in at 5 because it's less than or equal to, and x is going to be any value less than or equal to negative 5. All right, number 2, same idea, except now we have a fraction to work with. Okay, so let's let's set it up as an equation, and this one's going to be just a little more complicated because of the numbers. All right, but let's do this together. So we're going to have 4/3 x plus 3, and we're going to set that equal to 23 over 3. First thing I want to do is subtract 3 from both sides. So I'm going to subtract 3. Subtracting 3. Well, 3 is the same as, let's do it like this, is 9 over 3. And the reason I just did that real quick is just to make it a little bit faster. 9 over 3 if I reduce that, becomes 3. So 23 minus 9 is going to be equal to 14 over 3. And that's going to be equal to 4/3 x. Now, let me just show one more way of doing that there. If I want to do 23 over 3 and subtract 3, I could turn this into a mixed number. 3 goes into 23 7 times with 2/3 remaining, right? If I subtract 3 from that, I end up with 4 and 2/3. And 4 times 3 is 12, plus 2 is 14, so I'm back at 14/3, which is what I have right there. So if that way makes more sense to you, you can certainly do that. Now I want to get the x by itself, so I'm going to multiply both sides by 3/4. By 3/4. The 3's cancel out, and this goes into, I have 2 2's in there, and I have 7 2's in there, so I know that x is equal to 7/2. Now my teacher edition, just for the first edition here, does say, I think it says 7/3, but the solution should be x is equal to 7/2, or I could be thinking of a different one at the time, but anyways, that's what I have there. So that's what the solution would be for part A. X equals 7/2 for part A. So that's also the same as 3.5, right? Is where we are there. Because 2 goes in there 3 times with 1 left over, so 3.5. Is this equality true when x equals 0? All right, so that's our boundary line. So now we have to decide which way is it going to go. Is x going to be greater than, and we had 3.5, is it going to be greater than 7/2, or is x going to be less than 7/2? So a number greater than 3/2 would be something like 4, and a number less than 3/2 would be something like 0. Okay, so now let's put that back into our equation to see if it's true when it's equal to 0. The first part was, is it true when it's equal to 0? So let's try this one out. So we have 4/3 times 0 plus 3 equals, is less than 23/3. 23/3. That becomes 0, so is 3 less than 23/3? 23/3 is the same we said as 7 2/3, so is 3 less than 7 2/3? Yes, it is. That is going to be true. So we would say, in this case here, yes, it's true. All right, because when you put 0 in there, it does work. So this tells us the direction of our inequality as well. And there we go. So now let's graph this out. We know that we're going to be at we're at 7.5, 7/2, which is 3.5. So I have 0, 1, 2, 3, and 4. 7.5 is 3.5. So we're doing a x is less than 7/2. We're going to draw an open circle here at 7/2, and then we're going to draw an arrow this direction to say anything less than that would be true. Okay, and so that's the idea for number 2. Number 3 says solve the inequality and then graph the solution on the number line. All right, so we have a little less space to work with, but we can play with it. Here we go. So solve this inequality. I'm going to go ahead and first I'm going to distribute 3 times x and 3 times 4. So I end up with 3x plus 12 is greater than 17.4. I'll subtract 12 from both sides, so 3x is greater than 5.4. I'll divide both sides by 3, and we're going to say x is greater than 5.4 divided by 3 is going to be 1.8. All right, so we're at 1.8 right there. 1.8. So x is going to be anything greater than 1.8. So if I plot this out here, and I'm just going to go ahead and graph it because there's no negative number in front of the coefficient, so it's just that. So I'm going to write down 1.6 right here, 1.7, 1.8, 1.9, and we know that x is going to be any value greater than 1.8. Not equal to, but greater, so it'll be an open circle right there. On our next one, we have solve the inequality, and this time here, though, we have a little different thing, right? We're going to multiply this out, and we end up with negative 3x. Negative 3 times a negative 4/3 is going to be a positive 4, is less than or equal to 6. So when I subtract, I have negative 3x is less than or equal to, subtract 4, 2. And now I have a negative in front of the coefficient, so I have to think about this a little bit more. If I made this an equals statement, like an equation, and set it equal like this, I would say that x is going to be equal to negative 2/3. So now I need to decide the direction. Is x going to be greater than negative 2/3, or is x going to be less than negative 2/3 to find the direction? A number bigger than negative 2/3 would be 0. A number less than negative 2/3 would be like negative 1. So let's plug that back into our equation. So let's do negative 3 times 0 plus 4 and decide, is that less than or equal to 6? Negative 3 times 0 is 0, so we have left with 4 less than or equal to negative 6. Is that a true statement? Okay, is x going to be greater than that? That is a true statement. So this tells us our direction is going to be that one. Again, once I have a true, I don't need to do the other one. I could, and I will for you just to show you. So we have negative 3 times negative 1 plus 4 is less than or equal to 6. Negative 3 times negative 1 is positive 3 plus 4. That becomes 7. 7 is less than or equal to negative 6. That is false, so it doesn't work. So this indicates our direction. We turned it into an equation, found our boundary, and then found our direction. So x is greater than negative 2/3. So to graph that out, I can make a negative 1, a negative 2/3, a negative 1/3, a 0, a 1/3, a 2/3, and a 1. Just plotting out 0 thirds there. So x is going to be any number, and we had it, I gotta look real quick, it's greater than or equal to, I should always write that, sorry about that. We're going to have a closed circle at negative 2/3, and it's any value greater than that, like that, right there. Okay, so in summary today, all right, in summary, it says the solution to this inequality right here or any other ones is all the values you could use in place of x to make the inequality true. If you to make it like an equation, we're going to be able to find a boundary which tells us where we're going to have true values and false values at. Once we find that boundary, we're going to check some numbers to see, is it going to be less than or greater than, to figure out the direction of our inequality. And that's the big idea with today's lesson. Let's pause there and then we'll do our homework together. Okay, so here we go. Today's homework for lesson 15. It says consider the inequality negative 1 is less than or equal to x over 2 and predict which values of x will make the inequality true. Complete the table to check your prediction. And then we have another one. All right, so which values are going to make that true? Doing some prediction stuff here. Let's see. So the way we go about doing this one here, and this is just, you know, how I would do it. I would do it as an equal sign. So negative 1 equals x over 2, and we multiply both sides by 2 to get the x by itself. So negative 2 is going to be equal to x. This becomes our boundary marker. Our boundary is here at negative 2, right? It's less than or equal to that. So now what we want to figure out is then, using that as our boundary, is x going to be greater than or equal to negative 2, or is x going to be less than or equal to negative 2? So we know that when it is negative 2, right here, just in this case here, if I plug in for my boundary, negative 1 less than or equal to, if I have negative 2 here, negative 2 over 2, negative 2 over 2, negative 2 over 2, that's going to equal it. And so when I have negative 2 over 2, negative 2 over 2 is equal to negative 1, right? So when I just plug that in, negative 2 over 2 is equal to negative 1. My answer right there is negative 1. That's what I end up getting because it does equal it. So let's pick a number greater than negative 2. I'm going to go ahead and just start with a 0, okay, plus it's over here. So when I plug 0 in to my inequality, negative 1 less than or equal to 0 over 2. Is this true? Is negative 1 less than or equal to 0 divided by 2 is 0? Is that a true statement? Is negative 1 less than 0? Yes, it is. That is true. So because it's true, right, this is a true statement, then I know that things on this side are going to be true. If I went to the less than side, I would be asking the question like this. I would say, well, let's look at negative 3. Is negative 1 less than or equal to negative 3 over 2? So that becomes negative 1 less than or equal to negative 1.5. Well, negative 1 is actually greater than that. This is a false statement. It's not going to work. This is negative 3 over 2 there. So knowing this is the case, that this is false and this side is true, and this is a greater than or equal to, we're going to look at our true statement and the direction of our inequality, and we would say that x is going to be greater than or equal to -2 is the solution for that inequality. So these would all be true values from this point here, including the -2, all the way that way. Now to plug the numbers back in, just to see what you'd end up with, -4/2 is a -2, -1/2 is -1/2, 1/2 is a regular half, 2/2 is 1, 3/2 is 3/2, and 4/2 is 2. Those become points on our graph if we were to graph that out and what those points would be. Okay, and that's the idea. So that's number 1A. Now let's take a look at the inequality where x is a negative x value right there. So what's the difference going to be? Well, let's again solve it real quick. So we have x is less than or equal to -x/2. All right, if we turn that into an equation, we would say it's equal to, like this. So we have it equal. This becomes 2 equals -x, and I can multiply both sides by a -1, so that -2 equals x. So again, we have the same boundary. Actual point, interesting, is at -2. That's our boundary point. But now let's see which direction it's going to be. Is x going to be greater than or equal to -2, or is x going to be less than or equal to -2? We plug in some points. What's greater than -2? We're going to go with 0, and less than we'll go with -3. So let's plug it in. So let's see if these are true statements. Is 1 less than or equal to 0/2, which is 1 less than or equal to 0? That is a false statement, because when I plug 0 into that right there, we end up with 0, and this is false. If that's false, that probably means this is true, but let's double check. When I plug -3 into here, I have a -3, right? This is like a -3/2, which becomes a +3/2, right? So because it's a +3/2, it's a +3/2. Is that greater than 1? Yes, it is. It looks like a minus there. Sorry, it is not. So this is a true statement right there. So knowing that that's true and that direction is true, that tells me my inequality is going to be x is less than or equal to -2. That will be my solution. But let's go ahead and put the numbers in. -4 is a +4/2, which is +2. -2/2, well, think of this, a -2/2 is -1, but making a -1 is a +1. This becomes a +1/2. All right, we have 0 there, and then we end up with a -1/2, end up with a -1, -3/2, and -2. Because x has to be greater than 1, the only places where it's greater than 1 happen from here to here. This is my greater than 1 category all through there. So in terms of a graph, we would say it's there all the way that way. X is any value less than or equal to -2. Okay, so that's what we do there again and again, same process. Number 2, Diego's solving the inequality. He solves the equation 100 minus 3x equals -50 and gets x equals 50. So what did he do? He found his boundary. All right, that's going to be his boundary, his upper or lower. What is the solution to inequality? Well, to find out the direction of that, we have to first take a look at a couple things. X is going to be greater than or equal to 50, or x is going to be less than or equal to 50. Less than or equal to, greater than or equal to the boundary. And it's greater than or equal to because that's the initial sign. Because that's our sign, I can actually eliminate choice A and eliminate choice C because they don't have the equal part of that inequality. So it's one of these two. So we want to decide which one is going to be true. So pick a number greater than 50. You could do a number like 100. Pick a number less than 50. You could pick a number like 0. And let's put it back in our equation and see if it's true. 100 minus 3 times 100 is greater than or equal to -50. Is this true? 100 minus 300 greater than or equal to -50. 100 minus 300 is -200 greater than or equal to -50. And is that true? Is -200 greater than or equal to -50? Nope, it is false. And since it's false, this is going to mean that this one would be true. Let's double check it. Okay, so we have 100 minus 3 times 0 greater than or equal to negative 50. That becomes 0. So is 100 greater than or equal to negative 50? Yes, that is true. So which statement is going to be our true statement? X is less than or equal to negative 50, choice positivity, choice B. Number 3, solve the inequality and graph the solution on a number line. All right, so what you might want to do here is solve it as an equation first, find the boundary, and then find the direction. So let's do that as our normal steps so far. So we're going to do negative 5 times x minus 1 equals negative 40. Divide both sides by negative 5, so x minus 1 equals 8. Add 1, x equals 9. Knowing that x equals 9, I want to now decide, is x going to be less than 9 or is x going to be greater than 9 to find out the direction of my inequality. So we could pick a number less than 9. Again, pick something like 0, right? It works. So negative 5 times 0 minus 1, is that going to be greater than, looking at here, negative 40? So negative 5 times a negative 1 is going to be equal to a positive 5. Is 5 greater than negative 40? Yes, it is. That is a true statement right there. Do I need to do the other one? Nope, I don't need to, because I know I found the true statement, so I'm good. So for this one, we would say x is going to be any value less than 9. And to draw that as a graph, we could have 0, we could have 5, we can have 9, and we can draw an open circle at 9 and an arrow going this direction for anything less than 9. Okay? Any less than 9. Great. Next one, number 4. Select all the values of x that make the inequality, this one, true. All right, let's do our same process. Let's make it an equation. Negative x plus 6 equals 10. Minus 6, so negative x equals 4. Multiply both sides by negative 1. That makes this an x and makes that a negative 4. So that's our boundary. Our boundary's at 4. So now we decide, is x going to be greater than negative 4 or is x going to be less than negative 4? A number greater than negative 4 would be something like 0. A number less than negative 4 would be something like negative 5. Let's use the 0 one and plug it into this equation. So we have 0 plus 6 greater than or equal to 10. I should make my equal sign there too. So is 6 greater than or equal to 10? Nope, that is false. So if that's false, what is our true statement going to be? Our true statement would be that x is less than or equal to negative 4. So that's our true statement. So I can look for anything where x is less than or equal to negative 4 to be something that is going to make the inequality true. Negative 3.9 is bigger than negative 4. 4 is bigger than negative 4. Negative 4.01 is less than negative 4. Turn the page, just keep on looking, there's more. Negative 4 is equal to negative 4, so that would work. Too big, too big, too big, and less than. So we're looking for any value where x is less than or equal to negative 4, so those ones work as well. Number 5. Draw the solution for each set of the following inequalities, where x is greater than 7. It's just greater than, so it's an open circle. So 7 would be right here with an open circle, and you want any number greater than 7, and that's what our graph looks like. Here, x is greater than or equal to negative 4.2. Negative 4.2 is somewhere about here, and we're going to have a closed circle because it's equal to, so negative 4.2, and our graph is going to go this direction all the way over there like so. All right, number 6. Number 6 says the price of a pair of earrings, this is a review, is $22, but Priya buys them on sale for $13.20. How much was the price discounted? So how much is not a percent, it's just the actual dollar amount. What was the discount? So we'll do $22 minus what she paid, which was $13.20, to find out how much she saved. So we'll borrow, right? Oops, borrow there, so it's 10. So 10 minus 2 is 8, and to borrow again, 11 minus 3 is 8. So what did she save? She saved $8.80 is what she saved. Now the question is what percentage, what was the percentage of discount? So the discount is going to be your original price times your discount, okay, times your discount is going to equal your your savings, what you saved. We know she saved $8.80. Okay, this is our original. So 22 times something, x, is going to equal $8.80 for her savings. So to solve for x, we'll divide both sides by 22, and x is going to equal, in this case here, x is going to equal 0.40. That's a decimal, so as a percentage, we move it over 2 spaces, and we end up with 40%. All right, that's it for today, and we will see you next time.